which called M1. Where is beam M1? M1, this beam. How can I get these labels? View, beam labels. View, beam labels. You got it?
Mm-hmm.
So M1, this beam called M1. Your M ultimate on this beam equal 13.26. M ultimate top. So this moment, I expect your bending moment on this beam something like this. Like this. This beam from here to here looks like beam supported here, supported here, supported here, and here, and here. We have load coming from on weight, coming from slab, coming from live load, coming from everything. My expected bending moment something like this. For member or for beam or part or beam M1, your top M ultimate equal 13.3. For the same member M1, your bottom M ultimate equal 5.8. Keep going. For M2, this M2, yes. I can tell you what is the moment at top, what is the moment at bottom. So moment at bottom, 17.2. Moment at top from this side, 17.7. Here is your M ultimate. What's next? Go ahead and design your beam. Or wait until you get all the value and use the biggest value. You can use the biggest value and make your reinforcement the same for the whole beam. So if you remember, if you have M ultimate, I can tell you what is the rho required. And I can tell you what is the area steel required. And I can check if this area steel required within the limit area steel minimum and area steel maximum. You learn it how to design. That's right. And right now you learn it how to define your building and how can I get the M ultimate from structure analysis for each part of your beam. If you would like to design more economic design, go ahead and do your design for each part alone. This one needs 4 bars. This one will need 5 bars. This one will need 3 bars only. This one will need 6 bars. Or another option, which is not economic enough, you can use the maximum value of your M ultimate and make your reinforcement the same for the whole beam. Yeah.
Does Risa tell you which beam is like the one that has the greatest moment?
No, you cannot. Each one you can look, or you can take all of this stuff to Excel and figure out which one is the maximum. Nobody noticed something else. For each member, we have phi MN, which is design bending moment. And he divided your required moment by the available moment and you got a ratio. If this ratio greater than 1, it's unsafe. If your ratio smaller than 1, you are safe. Wow. How did the program define phi MN? I cannot get this value until I have a cross section with a steel reinforcement. Yeah, you did. You defined your B 16 inch and your depth, I think 30 inch. That's right. But how much steel reinforcement? If you would like to make your design before solving, you can. Really? Yes. insert beams. Beams. Do you remember here?
Mm-hmm.
We defined here your cross sections, that's right? You can modify your design. You can modify properties and modify your design. Let's start. If you would like to modify your design, can I? Let's start with this one, modify properties first. No, this one for just a second. From somewhere you can modify your design, but I cannot remember how. No. Edit. Anyway, I will figure it out. You can define the how many listeria reinforcement in your beam, but I don't like to use this option because at the beginning I can tell you what is the depth of your beam, what is the width. I can assume it, but I cannot figure out how many listeria reinforcement because I don't have enough design. So I don't like to use the design by the program. I would like to use what is the structure analysis. Results from your software. So I can tell you what is the bending moment on your beam, and I can tell you also what is the reaction on each column. And I will let you know what is the bending moment in your slab to get your steel reinforcement in both direction, X and Z. So we need today to focus only on how to define your building on RISA, how to insert your point or joint, how to draw and define your beam, how to draw your column, your slab thickness, how to define your load, make your combination and solve. Next time I will let you know how can I use these results for slab, for bending moment and the deflection, and how can I get the full results for beam and column to design columns and beams and footing. Any questions so far? Everybody got my email regarding how to download the RISA products?
Yes.
Do you have issue with this? So until now, the original or the beginning for the beginner user, we learned how to use RISA 2D. RISA 2D just structure analysis course. Everything you learned in this course, you can use RISA 2D to solve it. Then we learned a little bit in RISA connection to design, or not to design, to check your connection, steel connection. The software can tell you this layout of your connection is pass or failed. Today, we started another software called RISA Floor. RISA Floor mainly from the name, for floors. Mainly reinforced concrete floors, which means beam, column, slab. There is another one called RISA Foundation or footing, I think footing.
Foundation.
Foundation. RISA Foundation. we may use it for footing. I'm not sure until now. Okay, there is another one called RISA 3D. RISA 3D is connected to RISA floor. This one just to solve your floor slab due to dead load and live load. But this one will solve your building as 3D building with floors to consider your lateral load, earthquake and wind load. This one more advanced. I think all of these softwares are products for RISA. Products for RISA. We learned RISA 2D last semester and this semester, this semester, this semester, and we will try to use this one. I will continue next time, next week, for RISA floor. How can I use the results from this software to solve?